Hello, students. I welcome you all within this online lecture series. Hope you people are doing good at your respective homes by benevolence and by grace of Almighty Allah. This internet gang is playing every now and then with our sentiments, with our feelings. Let's uh, discuss this structure of the diamond. Last time I gave you a short glimpse regarding the structure of the diamond. I told you people that this diamond is a giant molecule of carbon atoms, and each carbon atom in the diamond crystal is linked to the four other carbon atoms by strong covalent bonds. And the four carbon atoms are at the four vertices of the regular tetrahedron. I told you people, according to Liebel and the Van 't Hoff, they said in their statement that all the four valencies of the carbon are directed towards the four corners of the regular tetrahedron. And I told you people that this diamond is having rigid structure. Why? Now the question arises, why this diamond is having rigid structure bits? The great hardness of the diamond is actually because of the strong covalent bonds, or the strong powerful network of the covalent bonds which a diamond comprises. So let's talk about this diamond, and let's make this diamond more clear to you people. What actually I told you people in the previous lecture, that this diamond is a non-conductor of electricity. That means this diamond does not conduct heat and electricity. And now I told you people in previous lecture that why this diamond does not conduct electricity, because there is no free valency in the diamond. For example, this is I told you people that every single central carbon of the diamond is connected to four other carbons, or linked to four other carbons by strong covalent bonds to form regular tetrahedron. This is a regular tetrahedron, and each carbon, this is at carbon at 1, 2, 3, 4. Carbon is having atomic number of 6. That's in first shell it contains 2 electrons, in second shell it contains 4 electrons, and these 4 electrons are directed towards the four corners of the regular tetrahedron. And these four valencies, this carbon, central carbon, share with other carbon atoms and give diamond a definite structure. And there is no free valency. These four valencies are occupied. This valency number 1, 2, 3 and 4. Four valencies are occupied. There is no free valence electron. The moment there is no free valence electron, so diamond will no longer be in a state to conduct electricity, because the necessary condition for conduction of electric current is that there should be the free electron. But as far as diamond is concerned, there is no free electron. That's why diamond does not conduct electricity. That's why diamond is a non-conductor of electricity. And as far as uses of diamond are concerned, it's a lustrous shiny crystal, because I told you people, because of the lustrous nature of the diamond, it's a good reflector of light. And it's used for jewelry and ornamentation. Use it in tools, and machinery for grinding and cutting glasses. Using I can say cutters. Diamond actually dyes are used for drawing thin wires like tungsten filament of the electric bulb. All the use of the diamond is or because of its great hardness. Diamonds are also used for making jewelries. And one more important, I can say, the use of the diamond is that it's used by the eye surgeons as a tool to remove cataract from eyes with a great precision. So this was a short glittering glimpse of the last video lecture which I discussed with you people. So let's move forward. Let's discuss structure of graphite. So as far as this structure of graphite is concerned, the structure of graphite is very different from that of a diamond. Graphite crystal consists of layers of carbon atoms, or sheets of carbon atoms. I can say this is a one layer, layer number 2 and layer number 3. Look at another picture, layer. That means structure of graphite is very different than that of the diamond. A graphite crystal consists of layers of carbon atoms, or sheets of the carbon atoms, and each carbon atom in graphite layer is joined to 3 other carbon atoms by strong covalent bonds to form flat hexagonal rings. These are hexagonal rings. 1, 2, 3, 4 hexagonal rings. Hexag means 6 rings contain 6 carbon atoms. You will see 1, 2, 3, 4, 5, 6. That's 6 carbon atoms are linked with each other, and they form a, I can say, flat hexagonal rings. That's why I told you people that each carbon atom in graphite layer is joined to 3 other carbon atoms by strong covalent bonds to form flat hexagonal rings. And one thing you must remember, that the various layers of the carbon atoms in graphite are far apart, so that no covalent bond exists between them. For example, this layer number 1, this layer number 2, there is no covalent bond between the layers of the graphite. So as far as this layers are concerned, these layers are held together by weak forces, weak van der Waals forces. Look at this, weak forces, and these weak forces are also called as van der Waals force, because these were first seen by a scientist van der Waal, and that's why they are also called as van der Waals forces. Since the various layers of the carbon atoms in graphite are joined by weak van der Waals forces, they can slide over one another. Due to the sheet-like structure, graphite is comparatively very soft as compared to the diamond, and it is the softness of the graphite which makes it useful as a dry lubricant for machinery parts. So as far as this structure of graphite is concerned, structure of graphite is very different from that of a diamond. Graphite crystal consists of layers. These are layers of the carbon atoms or sheets of the carbon atoms, and each carbon atom in graphite is joined to 3 other carbon atoms by strong covalent bonds, and there's formation of flat hexagonal rings. The moment there is a formation of a strong flat hexagonal rings, and these hexagonal rings are held together by weak van der Waals forces, and due to these weak van der Waals forces, these sheets can slide with one another, I can say over one another. Due to the sheet-like structure, graphite is comparatively soft substance as compared to the diamond, and it's the softness of the graphite which makes it useful as a dry lubricant for machinery parts. Now the question arises, why this graphite is a good conductor of heat and electricity, and the diamond was actually the bad conductor of heat and electricity. Why this graphite is good conductor of heat and electricity? Because the central carbon atom of the graphite is linked to only 3 carbon atoms, because carbon is having valency of 4. That means it should share 4 of its valence electrons, but it shares only 3 valence electrons. This 1 and 2, this is 3. That means there is one free valency, and this free valency creates a hole, and whenever we pass electric current through the structure of the graphite, this hole actually conducts that very electricity. So that's why this graphite is I can say good conductor of heat and electricity, because there is a free valence electron. Now graphite crystal, each carbon atom is joined to only 3 carbon atoms by covalent bond. Thus only the 3 valencies of each carbon atom in graphite are used in bond formation. This is valency number 1, valency number 2, and valency number 3. And one valency is free because carbon is having atomic number of 6. In first shell it contains 2 electrons, in second shell it contains 4 electrons, and it shares only 3 electrons. That means only 3 valence electrons are used in bond formation. The 4th valence electron of the carbon atom is free to move. That means due to presence of the free electron in graphite crystal, it conducts electricity. That's why I told you people that the necessary condition for, I can say, graphite to conduct electricity is that there should be the free valence electron. But as far as graphite is concerned, it is having one free electron which is not taking part in the bond formation. The moment it's not taking part in the bond formation, ultimately it will conduct electricity. That's why I told you people this graphite conducts heat and electricity. And this was actually the structure of the diamond. Hope you people have enjoyed this. In next video lecture we are going to discuss another allotrope of the carbon, that's Buckminster fullerene. Hope you people have enjoyed this. In next video lecture we are going to discuss one more allotrope of the carbon, that's Buckminster fullerene. So let me recapitulate this, what I told you people regarding this structure of the graphite. The structure of the graphite is very different as far as compared to the diamond. Graphite crystal consists of layers. These are actually the layers of the carbon atoms, and these layers are joined together by weak van der Waals forces. The moment we will heat this structure of the graphite, the structure of the graphite can be disturbed by, I can say, by applying heat, because these flat hexagonal rings are held together by, I can say, weak van der Waals force, and it is easy for we people to break the network of this weak van der Waals forces. So that's why. And one more thing I would like to add here, that which I discussed with you people, that this graphite is actually the I can say good conductor of heat and electricity, because only three valencies are occupied, or can say three valencies are used or taking part in the bond formation. The fourth valency of each carbon atom is free to move due to the presence of the free electrons. Graphite crystal conducts electricity. Hope you people have enjoyed this. And in next video lecture, we will take this carbon and its compounds unit move forward, and we will discuss Buckminster full in another electron of the carbon. Till then, stay at your home, stay safe, and be blessed. Allah Hafiz.